Question 11.1 says in diagram, part KN, MN and KN are drawn in the circle with center O. P and Q is a tangent to the circle at M. They want us to prove that the theorem which states that M and Q is equals to K. So they want us to prove the time-cut theorem. First thing, if you look at your answer sheet, you'll see that there's 3 ways in which they do this. We'll just go through the first. The first two actually are similar, so we'll go through the first and the third one. Okay, so the first thing we want to do is construct a line. So we're gonna have a line that goes through N and also O, touching the circle. And we also construct a line from that point to M. So we're gonna go ahead and call that point R. So because the diameter Rn has a tangent P and Q, we know that the diameter should be perpendicular to the tangent. So we can say that O and WM plus M and Q must give us 90 degrees. We also know that R is equals to 90. And the reason being is that this is a angle and a triangle and a semicircle. So that's going to be angle in a semicircle. And that's going to be because the radius is always perpendicular to the tangent. Now we want to calculate that angle over there, which is NRM. We'll say it's equals to 180, which is the sum of angles in the triangle, minus, we know we want to remove R, and we also need to remove O and M. Now for the NMR, it's clear it's 90. For the ONM, we'll just have to rewrite this with regards to M and Q. So we'll say ONM is 90 minus MNQ. Then we can substitute those in. NRM is equals to 180 minus 90 plus 90 minus MNQ. We will get that NRM is equals to MNQ. And we can say that NRM is equals to K. And the reason being is these are angles in the same segment. So we've proven that M and Q is equals to K. For method 2, we're going to construct a line from O to N, and a line from O to M. We know that the angle MON is going to be twice the angle of K, and this is because it is an angle at the center, is always going to be double the angle at the circumference. Still focusing on the triangle we just made, we want to calculate these two sides. Now, because these two sides are equal, it would mean that those two angles should be equal. So we can say O and M is equal to O, M, N. Right. Now to calculate their values with regards to K, we'll understand that if we say O, N, M plus angle O should give us 180. Right? And that will say 2 O N M is 180 minus our triangle or our angle, which is just going to be 2K. We'll divide both sides by 2. We'll get 90 minus K, that triangle. Now, what we know is that our angle, this angle over here, this one, is going to be 90 degrees. Reason being is that this is a radius and it's tangent. So they are always going to be perpendicular to each other. So we can say that O and Q is going to be 90 degrees, and that's because the radius is perpendicular to our tangent. And then again, that would then allow us to say that if we're going to calculate what N and Q is equals to, we know that it's going to be equals to 90 minus the O and M, right? And that will again give us 90 minus 90 minus K, and that will give us equals to K. So we've proven again that M and Q is equals to K.